Hi, this is Peter Taylor. This week, a colleague asked me what my new book, Nature, Nurture, No, has to offer, or how it deals with classic issues, nature, nurture issues of feminism, and what she could do with it. And this fairly unscripted recording is a result of some of my puzzling over her question and probing and opening up new puzzles. Now, right at the beginning of the book, it says this is the third paragraph, the conceptual themes advanced in this book emerge from puzzling over positions and propositions of others that did not, for me, fit together. And I hope to encourage others in puzzle posing and probing. So that's what I think the question has done for me and will continue to do. Let's see how it goes. I think underneath everything I say, there's a deep issue that hasn't been well resolved in our language or the antenna we have about language. So it's represented in this diagram. Here we have two groups, A and B, and they have an average. And we're quite used to saying men are taller than women. So we're thinking about, even though we know women have a range of heights, more near the middle, but taller and shorter, and men have a range of heights. In fact, for heights in men and women, the overlap is greater than this picture shows. But we still want to explain the difference between men and women. We want to look for environmental factors and, say, genetic factors that explain this difference in mean. So somehow this variation becomes a secondary thing, and that's why it's a dotted line. Sometimes that strategy of explaining the groups and then maybe looking at the variation afterwards might work, but the assumption that it's always the way we look at the world, I think, is still deeply in our language. So let's see how that, by the end, I think you'll see how that emerges. Okay, so you can ignore this diagram for a while. I think the question about what nature-nurture debates have for feminism needs us to think about there being two approaches and therefore two nature-nurture debates, and then think about their relationship. So the first nature-nurture debate might be, I might call the developmental one, how an individual develops over its lifetime given, the egg, the fertilized egg that it begins with. The other one would be the difference between groups, or the difference across a population, which might be at any one point of time, and it might be in a snapshot. So we're certainly concerned with the developmental view when we look at, just this week there was a headline about boys and sexual violence. Why are so many primed when they come to college to commit sexual assault? So we're just talking about boys primed suggests that boys are the category. And so we know that boys in general have XY as their two sex chromosomes, and the girls or the young women have XX. So the question is suggesting, not insisting, but suggesting that there's something about boys and there's something about the XY that makes it natural that they're primed for sexual assault. Natural, it's the way it's supposed to be. Or that it's hard to change. Even if we wanted to change it, it's hard to do that. Or perhaps it's an entry point into investigating the development of individuals, looking at how the chromosomal differences lead to hormonal differences, lead to the way they're treated as infants and the way they go through adolescence in relationship to the media and the way laws are structured. So we go all the way from this biological origins through into our social context. And by looking at development, we might note points of change. But that developmental sequence begins with the chromosomal difference. Now, a contrasting view might start with the real world, start with various attempts to change the situation, change the behavior of boys and men, to engage with that. Why would we put special emphasis on the initial chromosomal difference? Well, I'm going to address this why in twice. The first time is kind of repetition of what I said before, that the genes are determinants of what comes after, or they're the root causes, and it's always better to understand the root because all the branches follow from the root causes in the unfolding development, or that they're harder to change, or that they're the key places to intervene, which may be because you think they're the root causes. But none of those whys, the whys of looking at the biology first rather than starting with the real world engagements, are logically correct, logically so. It's not necessary. And I think about a friend, Robbie Mack, who had muscular dystrophy. So there's definitely something in his genetics, and I'm not suggesting you can just sweep it away or undo that biological inheritance, which he had before he was even a social being. But when he was at school, particularly middle school and high school, his mother in particular, this was, we're talking the 60s, she, what we would call these days, mainstreamed him. She insisted that he participate in everything, and she mobilized his friends. You know, when he could easily get knocked over by a soccer ball, she mobilized that. And then when he had to be in a wheelchair, his friends were the people who pushed around. And so they became part of his social circle and continued when they all went to university. And that's where I met him. And by that time, he was living what we would now call independent living, which meant that people had to take it in turns to get him up, wash him, put him in the wheelchair, which is a motorized wheelchair. I mean, he was experiencing, as he went into his early 20s, the decline in motor function that comes with muscular dystrophy. Now, in those days, most people with muscular dystrophy died in their 20s. But he built upon that early mainstreaming in the high schools, and his friends continuing it when they went to university. He became, a central student advisor, and new generations of students became part of this community. And eventually he lived in a group house, and he had to be put in an iron lung every night. And later, after I left Australia, he married and was the parent for a child, and lived until his, I believe, late 40s, much longer than you're supposed to live. So the biology certainly got changed for the muscular dystrophy, but the significance of that muscular dystrophy went through many, many layers, none of which were determined by that genetic inheritance he had. And it's not. It wasn't simply Robbie Mack's will to live, the heroic story. In fact, he was a bit of a reluctant mainstreamer, and his mother had to really, from all reports, had to really push him into staying in the mix. So it's very much the social significance of that biological inheritance was very much constructed out of many strands and many elements. And if we wanted to alter the social significance for someone who had the same genetic inheritance as Robbie Mack, it would be a multifaceted project, and the fact that he had muscular dystrophy wouldn't be a very big, the specific genetics and biochemistry of muscular dystrophy wouldn't be a big factor in our ability to pull together that network. In case you think that's a special case, let's look at the poster child for genomic medicine, and that's phenylketonuria. Phenylketonuria is, like muscular dystrophy, a single a change at a single place on the genome that leads to an inability to metabolize the amino acid phenylalanine, so it accumulates, particularly in the brain, and causes retardation and usually early death. What they discovered by around 1960 is that you could test newborns, not for they didn't do genetic tests in those days, just for the biochemistry, and they could put them on a special diet, and the special diet prevented that severe mental retardation and the early death. So it's a poster child for genomics, because it says if you know the genetics or the biochemistry connected to the genetics, then you can change it. But in fact, there are very few things that have followed that. And even for that, and that's what this diagram is going to be about, it's like the Robbie Mack case, it involves quite a complicated set of intersecting strands to work well. So the first strand would be the PKU person's medical condition, that they have PKU. The diagnosis, the neonatal diagnosis, has been put into place in all states, I think, in the United States and many other places in the world, leading to a special diet. Social support is mandated testing. It wasn't mandated at first, that took some decades. And a wider social context, it certainly got a kickoff in the early 60s with John F. Kennedy being president and one of his siblings being retarded, and people hoping that a lot of mental retardation might be amenable, like PKU, to biomedical remediation rather than the psychological work or the asylums and so on. But if we continue over time to look at the 5- and 6-year-old, often the special diet is only covered by insurance if you have insurance. So here we might put social support to 5 and 6 years old, so it's harder to maintain afterwards. And it's certainly harder in our world with teenagers and peer group pressures for the teenager to maintain the diet. It's also a little bit harder when the teenager becomes more independent and has to look after themselves. They may not be perfectly as sharp as they other on average or other kids in terms of doing all the sums that are needed to put together the right quantities to maintain the diet well as they go into young adulthood. And through all this time, the social support includes the support of the family and the community, which might have religious dietary considerations, which are hard to match to the diet. Also, working parents, it takes quite some time. It's not just the expense of the diet, it's pretty bland. And teenagers want to be independent of constraints. So there are many different strands have to go together to have that result. The genetic doesn't mean unchangeable, to actually keep that care of the person with the PKU condition. And there's also a new outcome that's emerged over time, and that is if the young adult is a woman and isn't keeping to the diet perfectly and is pregnant, then the fetus will be exposed during gestation to high levels of phenylalanine, which are damaging to its brain development, even if it doesn't, as it won't have, the PKU condition. And they call that maternal PKU. And that's a new thing which didn't used to exist. Hardly, I don't know if there's any known cases before of PKU people living long enough to have children themselves. So even in the poster child where there's definitely a genetic condition, knowing it doesn't only begins to tell you you need the special diet, but doesn't contribute very much to understanding how to maintain the social supports, certainly not how to create a medical insurance system that's accessible to everyone in the United States, and to have the diet affordable by everyone, and so on. Anyway, another case that I often use in my teaching to try to illustrate this point that knowing the root causes, knowing the genetics is not necessarily the key to being able to address it, address the implications. This diagram is adapted from the developmental psychologist John Bowlby, and he was trying to represent the work of medical sociologists Brown and Harris. And in the early 1970s, they analyzed data from the late 1960s of the higher incidence of clinical or hopeless depression in working class women in an area of London. So we're not saying this is all working class women in all parts of the world for all time clinically depressed. They're just looking at the higher incidence. And they were able to, by their method, which is very interesting mix of qualitative and quantitative work, able to associate it with these 5 factors in a box. In the previous year, so this again is time across here, in the previous year or 18 months, there'd been some severe event that had happened to them. But they were more likely for that severe event, see the dotted lines don't mean determined, but more likely, if they also had an unsupportive partner or a lack of a partner altogether. And also if they're in chronically difficult living conditions, which were more likely if they lacked a partner or had an unsupportive partner, but also more likely if they had grown up working class. But then there was this factor from if they'd lost their mother or primary caregiver, leading to a lack of care before age 11 was also a factor. So this predisposed them or set in train. And this is where Bowlby comes in. He was saying this loss of a parent in your childhood sets in train for him the increased likelihood of anxious attachment, childhood helplessness, and low self-esteem, which continues to current helplessness. So he added this psychological strand to fit his own views. And so in my teaching, I say, imagine if there were a genetic strand up here as well. Something about your genetics led to biochemistry, which meant you are more likely to be an anxious attachment baby, which makes it more likely that your family reinforces that you don't connect as well with them. Then, and that genetics isn't going to go away, and the biochemistry isn't going to go away unless perhaps you take some prophylactic antidepressants. So maybe you do that and make it less likely you feel currently helpless. Okay, so if that were true, it's just completely hypothetical, that would be one form of intervention. But of course, taking something over your whole life might have side effects, and it's only one of many places where someone could intervene to try to reduce the incidence of hopeless depression. So for example, one intervention has been to try to create what Americans might call buddy pairs, people to talk to. Just having someone to talk to in advance, prophylactically, can mean the severe event is less likely to lead to hopeless depression. Also, with the lack of care in the late 1960s, the young children would often end up in institutions, and one way girls got out was by an early partnership and an early pregnancy. And those early relationships with having children make living conditions more difficult, and those relationships are less likely to survive, so it's less likely you have the supportive partner. So you might make these custodial institutions more humane, less places to escape. You might make better contraceptive counseling. You might make, if you add Bowlby's, a lot of work on counseling in schools for self-esteem. You might make social welfare policies that make working class life less chronically difficult. And so there are many points of intervention. When I say you, different people have different skills, different abilities to get engaged in that situation, and some of them require collective efforts like lobbying for social welfare policies. So again, there's nothing specific about if you'd found this genetic predisposition to anxious attachment that says that's the root and therefore that's the best place to get involved. So what's this got to do with feminism? Well, we'll have to get to it. Now, when I say there's nothing special about identifying the root cause, there's also costs in emphasizing that root cause. So if we, in other words, of not examining all the rest of this matrix that is layered on top of it. And the costs are, if we think of something like BRCA genetic testing for women, BRCA1 and BRCA2 genes, they're only involved in a fairly small proportion of breast cancers, but they certainly having those genes increases your chance of breast cancer or ovarian cancer quite a lot. So there's a big push for people to be who might have breast cancer in their family to test whether they've got BRCA and then decide whether they're going to take prophylactic measures like mastectomies or ovarectomies. And now, in the last couple of weeks, I saw there's a push for everyone, not just people with BRCA genes in their breast cancer in their family. But all that effort to do that is distracting attention away from looking at what is it that caused the great rise of breast cancer through the 70s into the 80s and flattening out in the 90s. You know, we're not invested. You know, the proportion of BRCA genes certainly didn't increase during that time. And so we're not looking at any of that. And in fact, it's flattened off and gone down slightly in the last decade. No, in the 90s to the mid 2000s and flattened off since. So we're also not looking at why it's gone down. Again, that, you know, if we understood that, we might be able to extend that effect. And we're not looking at the geographic variation to try to understand the contributions, both within the United States and worldwide. So that's what I mean by the costs. It's like there are a lot of other things that might help you prevent breast cancer other than testing for the BRCA genes and then deciding that, well, it's not certain that they'll lead me to breast cancer, but the only way to get certain is to remove those breasts. Here's another case where I think it's very interesting. 10 years ago, husband and wife team, Caspi and Moffat, and their different research colleagues came up with two big studies, and one of them that looked not just at genes, but at some social context to try and look at the combination, but just one and one, no sort of network like I've been showing. And what they showed is that if you had low MAOA as a child, and depending on whether you were maltreated as a child, not at all, probably, or severe, your antisocial behavior as an adult on average climbed up. If you had high MOA, in fact, you know, probably antisocial behavior without maltreatment was higher, but then it just didn't, you weren't so susceptible to becoming antisocial if you experience maltreatment. They suggest at the end of the article that there might be some prophylactic treatment that would lower your MOA, raise your MAOA. So it would lower your, it would bring you down to this curve. Of course, we could also say there might be some prophylactic work to eliminate maltreatment, because if you didn't have any severe maltreatment, you know, this isn't very different. In fact, it's the all comes out in the wash here. So it's interesting that they didn't suggest that. But of course, eliminating childhood maltreatment involves a lot of things that aren't necessarily good for everyone. Prophylactic MOA might also have some lifetime effects, like the hypothetical antidepressant that I mentioned for the Brown and Harris case. But one of the things that they don't highlight in this work is that these are averages. So if we have a range around the average, we find that some people who had low MOA and severe maltreatment didn't end up as antisocial as some people who had high MOA and maltreatment. So if you use these results to say, okay, there are some people who are more likely to become antisocial if they're treated badly. Let's identify them early and put special effort into, focus our effort into making sure those people weren't maltreated. What you'd be doing is you'd be putting all these people in this range, including the ones who were going to end up at the low end of the range, into the type being they're all low MOA. They'd all be treated as if they're potential, like bombs going off. And you'd be letting all these ones off, even though some of them were going to be part of this, the ones at the high end of the range are going to be part of this antisocial group. And so again, that's another kind of cost. The cost of people being treated as if they're part of their group's mean without paying attention to the way they vary around the group mean. And it certainly has an effect on you if you grow up your whole life being treated by teachers and parents as someone who needs to be either treated with kid gloves so you don't blow up, or treated with stern, you know, with the rod so you don't blow up. Either way, your particularity, the particular place you have in the variance or a variation around the mean, is not paid attention to. Okay, I said there are going to be two parts to why people might focus on the genetics and not as sort of some roots, and not get involved in the complex networks of growing up in a social context in a way that gives social significance to whatever biology we bring with us. So the second one reason why you might focus on the genetics is that there's a big biotech and pharmaceutical industry which is pushing for more and more genetic research. Pushing for it in the hope that enough things will be found where the genetics can be connected to the biochemistry, and the biochemistry can then lead to some drug treatment that could be sold with enough profit. So you have to have enough people involved who have that genetic condition. Sometimes, just to keep research going, the rare conditions, the orphan diseases, also get addressed by researchers. But the main thing the big pharma is going for is drugs where they can make money. And big pharma doesn't make money off changing the social welfare policy, which reduces the difficult living conditions for working class women in London. Okay, I think that's a big elephant in the room, but I'm going to put the elephant into the corner and suggest another reason why people might push for it is that there are long-standing discussions of such and such a trait has a heritability of 50%, 60%, 70%, 80%. So that kind of says to people, heritability, that kind of says, okay, if we're going to put in our effort, 50% is genetics, so let's put a lot of effort into genetics. And let's look, this is a table of heritability. Alcoholism 50 to 60%, Alzheimer's 58 to 79 the estimates, anorexia 57 to 79, asthma 30, bladder cancer is lower, blood pressure, body mass index, obesity, Crohn's disease, epilepsy, heart disease 30 to 50%. If you go long enough, they have ones which have likelihood of divorce and political parties you vote for, but I don't think they're listed in here. Schizophrenia 81%. So these figures are around, and they kind of suggest that, if we're going to decide where to put our funds, we should put them maybe in proportion to how much is genetics. Now I need to address this work and this assumption that these heritability estimates are a good guide to genetic influences. And this, in fact, is more of what the book Nature, Nurture, Know is about. It's not so much about how we get involved with development of traits over time in their social context. So if there's a nature-nurture issue about development of an individual, that's one thing. This is a nature-nurture in the sense of if it's 50 to 60% nature, like genetic, then the rest is nurture or just noise. Okay, so heritability sounds like heritable. And heritable is what we call something that gets transmitted through the genes. Oh, these days we do. Heritable used to be whether you could pass your property on to the children and so on, whether it was something you could pass on to your children. Well, heritability is the classic definition of heritability, which dates back to the almost 100 years ago now, has no reference to genes. They didn't know what DNA was then. They were just barely being able to map the position of some traits, like white eye mutants in fruit flies to certain places on the chromosomes and so on. It was the heritability particularly came from agricultural research, and it was based on analyzing the variation in traits, what you could observe, not these genes which they didn't even know what they were, let alone was able to observe them. There is, however, a new heritability that's the term has become used in the last less than 10 years really to refer to how much of the variation in a trait, say in incidence of heart disease, can be associated with particular places on the genome. So now that we can sequence the 3 billion base pairs on the human genome, we don't know where all the genes are, but we have ways of mapping things close to genes. They're called SNPs. And so they're able to associate SNPs with, if you have a SNP versus don't have a SNP, with certain increases in disease frequency. That sounds good. It sounds like we're connecting particular genes to these traits. The trouble is, after just a few years of doing these studies, they're called genome-wide association studies, they found that they found no places that explained very much of the variation at all. If you added it up, maybe they explained 5, 10%, maybe sometimes 20% of the variation. And so they said, so we know these things have heritability, say height is here 81%, but the genes we're getting are only showed 20, so they said there's some missing heritability. Well, looking at how much you can associate variation in traits with variation in specific genes is a different form of heritability from this classic one. But still, it indicates they hope that these figures gave them a hope that they could find more and more genes, or at least some genes with a big effect that they could then try to understand the biochemistry related to those genes and go from there. But the program didn't turn out to work that way. But I think we can begin to see why it didn't work that way if we go back to the classic heritability and try to make this accessible for non-biologists. And we can think that a classic way that you would come up with a figure of heritability for some trait, let's say the trait is height in humans, is that you would look at twin pairs. So dizygotic twins raised together in the same family, two twins, are not as similar, that's why these points are further apart, than monozygotic twins, identical twins raised together in the same family. So these pair are raised in this location, this family, this pair are raised in this location. And you see that the fraternal twins, the brackets are bigger than these, so that the identical twins are more similar. And it's completely reasonable, given that these twins were raised in the same family, to believe that the extra similarity, the closeness of these, is because they share all their genes. Well, these don't share all their genes. They share half of the genes that vary in the population. They share most of the genes because we all share most of our genes, but of the genes that vary in the human population, these share just a half. It's possible to argue that these raised together and they're identical, so they're treated more similarly. But that's an objection, and people keep arguing about it. But it's a reasonable thing to at least think that because these are closer together, it's because they share more of their genes. And so you can create a formula that compares the closeness of these and the closeness of these and turn it into this figure, heritability. So let's put aside the objection that these must be treated more similar, and that's the cause of them being more similar. But this whole analysis of traits, there are no genes being analyzed, doesn't allow for this issue. So we shift to color here, but it's the same picture. That the genes which these two share, genes come in pairs, and then environmental factors that they share are actually different from the ones this pair shares. And the environmental factors are different from ones these share, and they're different from one these share. This is what I call underlying heterogeneity. There's nothing in the analysis, there's nothing in the method that creates these figures of heritability, which remember were 81% for height, 81% for schizophrenia, that says it's the same genes causing the height in this pair as in this pair. That there are different ways of getting to have height. That makes perfect sense when you stop to think about it. You know that some people arrive at their height they start growing at 10 and shoot up, and there's some don't start growing much till they're 16. You know that some are tall to the waist and short in their trunk, and some are short to the waist and long in the trunk. Some people have tall heads and some people have short heads. So you have a sense that there is a heterogeneity in this very thing that we can all measure of height. So we can easily imagine that there are heterogeneous paths underlying this trait. And we might say, well, we could imagine that for heart disease too, for IQ test scores, for schizophrenia, particularly schizophrenia. There are people who argue that schizophrenia is certainly not one condition. Maybe we wouldn't imagine it for PKU because we have pretty straightforward biochemistry that can be related to changes at a single place on the genome. But somewhere in between the PKUs and the IQ test scores, we start to get into the socially significant issues which people argue a lot about, the behaviors rather than the particular genetic conditions like PKU or Huntington's disease and so on. And somehow this idea that we've got some conditions like PKU have slipped into the way we think about these other conditions like height and schizophrenia. It's as if there could be genes for schizophrenia. That was a kind of discussion that was very widespread in the early 20th century, in the early phases of eugenics. People, once they'd identified, rediscovered Mendel's theory, they started to suggest genes for anything you wanted, and then try to trace them in families. Not terribly successfully, but it was all tied up with the laws for enforced sterilization and so on. So people went a little bit quieter after the World War II and the Nazi use of those same kind of eugenics, but this sort of idea that we could have genes for things, genes for height, is still part of our discourse, when in fact, certainly genes contribute to the height of these twins, genes contribute to the height of these twins, but if they're different genes, we can't say there's a gene for height or there's genes for height that we could identify and we all have. So there's very little you can do with the knowledge that there's heritability for schizophrenia unless you happen to have a trait, and I don't think schizophrenia is one, in which everyone who had schizophrenia has the same sequence of genes, not different sequence of genes. And that, as I said before, is part of the kind of argument being made. The nature-nurture no is saying basically this division into 81% nature and 19% the rest is just not very helpful or interesting, and not the basis of social policy or even a good guide to deciding that this trait versus that trait would be worth doing molecular research to try and find out the genes involved. And it's also, in my mind, explaining why the genome-wide association studies have come up so empty. So many, there's so many genes, but the biggest effect they have is maybe increasing the risk of getting a disease to a risk factor of 1.5, which is very low. I won't go into the technicals here. Now, some of what I'm doing in the book might seem a long way away from feminism. Here you see a plant and a watering can and measuring. And a lot of the origins of the examples and of my own thinking on this come from having an early career where I worked in plant breeding. But if we think about what plant breeders are able to do, I think we get another kind of reinforcing insight into why this heritability in the classical sense is going to give us very little insight about the genetic influences. What I've got here is an ideal agricultural trial. We have, like before, we have 8 locations, and now instead of twin pairs, I'm calling them varieties. But the thing you can do in agriculture is you can grow this variety, same variety, many different seeds from it. The seeds vary because they're not always identical seeds. They may be from a mixed population, but you can randomly sample a mix. So you're getting a similar mix and grow it in location 1, 2, 3, 4, 5, 6, 7, 8. Then you can take them from variety B and grow them in the same 8 locations, and then variety C and so on. You've got an incredible control ability to replicate the material. And what you find if you are involved with plant breeding is that you can get some patterns. Let me just show you a picture of the kind of patterns we might get. This actually comes from, I think, wheat, 49 varieties of wheat in 63 locations in the world. And the 49 have been grouped into, what have we got, 10 different groups. So they've been grouped according to how similar they are in the way they respond across these locations. And what have we got? 9, maybe we've even got 10 locations too. And you'll see that, some of these groups go up and down in the same locations. These ones, even though they've got this big dip here, tend to go up higher because that's going up to 7 tons per hectare. This is only going up to just above 5 tons per hectare. This is even a bit lower. 1, 2, 3, 4, 5. This is intermediate. But by looking at which of these varieties are going up and down together, the plant breeders, the people who knew the material well, were able to say, what's in the pedigree of these varieties here? What are their ancestors? Is it some Ethiopian variety? Can we think about what that variety was like, whether it was susceptible to or resistant to fungi, rusts? And so they can think about the characteristics of the locations that make rusts or fungi more common, and invent some hypotheses about what is it about the ancestors, the pedigree of these varieties that makes them share patterns of going up and down in the different locations. They're just making hypotheses though. They then have to go and test them, and perhaps they might test them by saying, okay, this one was susceptible to rust, but the rest of its group was pretty resistant, so let's breed this across and grow them out in the locations, and some of them will be susceptible to rust and others won't. The ones that are susceptible we'll throw away, we won't use for future breeding, and so on. So we get some limited insight, even though we have incredibly rich data sets which are far more rich than you can ever get from the human twins. If you remember the picture of human twins, there were 8 sets of twins across that whole graph, much sparser than the picture I was showing you before. You get some hypotheses, you can then breed them, something you can't do with humans, and although maybe there was certainly an idea of human breeding back in the eugenics 100 years ago, maybe it's still implied deep down, not even recognized, when people continue to use heritability. Anyway, so you can get some hypotheses and you can do something with them, and even when your hypotheses are wrong, you're not so worried because you can discard the ones that don't do very well. All sorts of things that you can't do with humans. So you have to wonder why people would bother with this quantity called heritability, the classic quantity called heritability. Well, I think to look in that, I said there were some deep questions to look at that, and perhaps it'll help us bring us back to the feminist questions. We think about one variant of the idea of variation across a population, and that is when the population is divided into two groups, and we find there's variation for the trait X, maybe its height, in the two groups. And there's an average of that variation, and there's an average for that variation, and there's a gap between them. So we might try to think about explaining the differences. So we can think about explaining differences both in why things vary across the trait varies across the range, but differences in terms of between two groups. And we might think that there's going to be some relationship to our explanation about this variation, these differences, and these differences. Now, one thing I should say before going any further is we might observe differences, but that doesn't say that between the two groups like this, it doesn't say that that's the way it should be. It's the right way for it to be. It's definitely not saying that inequalities in power and access to resources should be based on these inequalities. It's not saying it has to be that because you see this pattern, maybe you see it for some generations, but it's not saying that it has to be that way forever. And it's not necessarily even saying it's the default, meaning if you try to deviate from there, that's unnatural, that's difficult to do. Maybe this is a place where you pick up some sport examples in Title IX. There were lots of sports which girls and women were not even allowed to be involved in, and with Title IX they got involved, and there has been a difference, and that difference is reduced. I'm not saying that the marathon times for men and women have converged to be the same, but they certainly have made, both groups have made improvements. I guess improvements meaning the marathon time gets to be less. I don't know which way to go on this figure. Well, one of the things we find if one group is women and the other group is men, is that almost all traits that people argue over have this kind of overlap. Different traits of personality, different traits of height, obviously, different traits of strength, fidelity, hairiness, chest measurement. Hold on, you might say. If we overlap so much, how do we so neatly readily tell men from women? Well, we do make mistakes because there are definitely people who don't, I don't know whether you should call it a mistake, but don't live their genital gender identities in social life, and we don't necessarily know about it. So we're thinking we can tell genital men from women. But most of the time, that example points out something, is we don't actually classify this person as a man and this person as a woman according to their genital sex. We classify them according to the trappings, the clothes, the hair length and style, the makeup. You might say, hold on again, but you know, women have breasts, don't they? And men have beards. Well, these things can be accentuated or de-accentuated. We just choose in a particular culture to accentuate them. And, you know, consider just how long some women passed it during the Civil War as soldiers. You had to be a male to be a soldier. So in that place where the trappings were fixed, people didn't wash every day and so on, they could pass for a long time. In any case, if it were just for beards, breasts, genitals, these wouldn't be it would be an issue about sex, not about, there wouldn't be an issue about the relationship between sex and gender, it'd just be sex and sex. Okay, but you might also say, look, you get this overlap for one trait, and you get this overlap for another trait, but if you put the two together, then you don't get so much overlap. And that's a clever and important point. So here we have height and waist, and we have an average for females in height, and we also have an average for females in waist, average for males in height, sorry, average for females in waist, average for males in waist is lower. So we have a range in both, and yet the squares are the males and the triangles are the females. And with this line, this is a pretty idealized example, but you can completely separate the females from the males. So if you use these two conditions together, you know, maybe a person has a waist that's around the average for women, but they have a height which is above the average for males, and so we're able to use those two qualities. If we knew nothing else about the people, we weren't looking at them with clothes on, without clothes on, we would be able to put them in the right category. I forget exactly what this formula is, and it's not perfect when you take a sample of, say, college students and so on. But I remember doing this in a multivariate statistics class. So you might say, if that can be the case for physical characteristics, why couldn't it be the case for, say, personality traits or intelligence traits or behavioral traits? Well, the answer is it possibly could be. It's an empirical question. It might require more than two dimensions. It might require a formula that connects a lot of different traits together. I don't really know the literature here, but I do recall an article that was looking at racial group differences and you know, the measurements of the face and so on. And they developed you were able to develop a formula which allowed you to discriminate what the race as people were identified, or as they identified themselves using census categories in one region, you know, like southern Missouri. But then you'd need a different formula to be able to discriminate them in South Carolina or in Indiana. So one's ability to do this work, if you wanted to tell groups apart, you may think you can do it, but it may have to vary from place to place, be, you know, customized to the place. And I think that would be ditto for men and women in these other characteristics. Maybe waist and height you can work with. But then you might also say, you want to avoid taking the next step, which is to assume that once you're able to separate the males and females based on two characteristics, or maybe two behavioral characteristics, then the other characteristics, they would also separate the same way on. They wouldn't overlap. What's more the case is we'd be back to here for every other characteristic. The fact that you found two or three that helped you separate them doesn't mean the other ones don't still overlap. So that people don't fit to, once they're separated on some, to being separated on the others. And you certainly don't want to treat them as if they're well represented by the average of their group. In all traits, we have a range. So remember, we began by two approaches. One was the development of an individual, and the other one was differences across groups. So what insight do we get when we look at differences across groups that might help us think about the development of an individual? And so far I've suggested that putting you into one group versus the other may work for some combination of characters, but there's nothing in that ability to separate people on a certain combination that says they don't overlap on the others. So I think there's some, going back to my very original point about there's some deep logic about the way we think about categories, human categories, and gender is one of the big human dichotomies that is being subverted more and more these days as we have the different trans categories. But there's definitely this approach which we have developed and is in our language. We don't say, for example, that, well, here we think about the two groups and we think about explaining the difference. Perhaps we're a little bit, we do think about the variation, and we think about explaining the difference according to the environmental genetic factors, and we think about explaining the spread within the group by the environmental genetic factors and so on. You know, if this were height, we'd say, okay, men and women, men on average are taller than women, and we associate that with the fact that there's the XY versus the XX chromosome. So the first cut is to explain the average. And then among them, among the men, well, there are lots of other factors that affect their height. Among the women, there's a lot of other factors. So the first cut is close to this issue that the mean is the key thing. But we could have a world where we just say, no, there's a spread for both. And there's a center point to the spread, and the center point of this group is a little bit across to the right from the center point of this group. And you notice in this case, I put group B in location B. So if this was males and this was females, I'm saying that the experience of growing up male makes your location, your environment, different from this group too. So it's not just essentially about the group. And if we had to examine that, we could be open to this possibility. Here we've got these spreads, and here you've got some crossing lines, and those crossing lines are supposed to represent that the way you get, these are two genetic factors and two environmental factors, I can't draw more on a graph, the way you get to this point for the women may be different from the way, maybe more similar to the way you get to some of a similar point for the men than it is to a similar point for the woman. There's nothing about the spread that says the first cut has to be male versus female. It could be that there are some men who share more of the influences genetic and environmental that lead them to this, whatever the trait is, height, than they share with other men. They share more with some women than they share with other men. There's nothing in the data about spreads and about the world being able to be divided into the groups which says that there couldn't be underlying heterogeneity. You might say, how could you expose what those characters are? That's really complex. Well, if it's the way the world is, that's what we've got to work out how to deal with. And that's part of why why in my book we need to put aside the nature-nurture that says, 81% of height is nature, and the rest is nurture. And why, when we're thinking about the difference among groups, we need to put aside thinking about the difference being something which doesn't have to pay attention to the underlying heterogeneity of the way the individuals vary. My final note is to say, people might say, luckily these days we're finding out more and more about genes and when they're active, so we can sort of build up these pictures. But in fact, I think we're finding out more and more about the genes which give you these effects which can be applied to a large enough set of people that drug companies could imagine capitalizing on them. We're not actually getting at these individual trajectories of genetic and environmental factors over their lifetime. We're not getting at the way individuals develop over their lifetime. And for that, I think we would be well advised to not put 81% of our work on genetics if this heritability is 81%, but recognize that there's nothing in that figure that rules out underlying heterogeneity of the underlying environmental as well as genetic factors. And we'd be better off putting it into real world situations where people have made efforts to intervene in development, for example, of male sexual identity and assumptions, and work with how difficult that is. It may be quite difficult, and that difficulty may be very little to do with the fact that the two boys in front of you both have Y chromosomes, and the two girls in the other room both have two X chromosomes. They may share very little in common beside that in the genes that are on those chromosomes, the genes that are on the other chromosomes, but they may share a lot more in terms of their ability to be influenced in relationship to these matrices or networks or intersecting processes of conditions over their lifetime. So that's my puzzling. There's definitely parts of that need more thinking, but I welcome any responses to it. Thanks very much.